Right now, as you're watching this video, your brain is processing mathematical equations that describe the electromagnetic radiation hitting your retina. Every photon carrying this information follows precise mathematical laws, traveling through a universe that might be nothing more than an incomprehensibly complex calculation. Yet here you are, feeling the weight of your body in your chair, experiencing the warmth of sunlight through a window, sensing the solid reality of everything around you. For over a century, physics has been telling us something that should disturb us deeply. Everything you think of as real, your body, this room, the earth beneath your feet, might just be mathematics in motion. Not described by math, not governed by math, actually made of math. Pure abstract equations, somehow generating the rich, textured, undeniably physical world you experience every moment of your waking life. This isn't some fringe theory. It's the logical conclusion of our most successful scientific theories. Einstein's equations don't just predict how spacetime behaves, they might literally be spacetime. Schrödinger's wave function doesn't just describe quantum particles, it might be all particles actual. LIAR, the standard model, doesn't just explain fundamental forces, it might be the only thing that exists, with everything else emerging as mathematical consequences. But here's what makes this profoundly unsettling. If the universe really is pure mathematics, then your sensation of touching a solid table, feeling pain, experiencing the color red, these aren't interactions with physical matter. They're somehow arising from abstract mathematical relationships that have no inherent physicality whatsoever. That warm cup of coffee in your hands right now, according to our best physics, it's literally made of nothing but numbers and equations. This creates what philosophers call the hard problem of consciousness meeting the mathematical universe hypothesis. How do abstract mathematical structures generate subjective experience? Why does touching fire feel hot instead of cold, or feel like anything at all? If consciousness is also mathematical, why doesn't it feel like solving equations? Why does reality feel so stubbornly physical when it might be completely abstract? Tonight, we're diving into one of the deepest questions humans have ever confronted. We'll explore how mathematicians discovered that reality might be computational, why physicists now suspect space and time are emergent properties of abstract information, and how neuroscientists are beginning to understand why mathematical processes feel like rich sensory experiences. We'll encounter the scientists who believe consciousness itself is a mathematical structure, and discover why some researchers think the feeling of physicality might be the universe's way of hiding its true mathematical nature from us. Along the way, we'll uncover three profound realizations that will change how you think about reality forever. First, that what we call physical laws might actually be the universe computing itself into existence, moment by moment. Second, that your consciousness might be what it feels like to be a self-aware mathematical pattern embedded in a vast computational cosmos. And third, that the apparent solidity of reality might be the most sophisticated illusion ever created, not by some external deceiver, but by the mathematical structure of existence itself. The implications are staggering. If the universe is made of math, then every thought you've ever had, every emotion you've felt, every sensation of being alive and aware, all of it emerges from pure abstract relationships that exist nowhere and no when. In particular, you're not a biological organism that learned mathematics. You might be mathematics that learned to feel biological. If you're ready to question the very nature of reality itself, subscribe and give this video a thumbs up. And here's something to consider as we begin. If consciousness is mathematical, and mathematics is universal, what does that suggest about the cosmic prevalence of awareness? Comment below with your thoughts. I'll pin the most mind-bending response. This journey will take us from the foundations of mathematics through the frontiers of physics and consciousness research to philosophical territories where science meets the deepest questions about what it means to exist. Some of what we'll discover might feel impossible to believe. Some might feel like it threatens everything you think you know about being alive in a physical world. But remember this, reality has never asked for your permission to be strange. Now let's begin our descent into the mathematical depths of existence itself. Chapter 1, Pure Foundations. What if I told you that mathematics isn't something humans invented to describe the world, but rather something we discovered that the world is made of? This isn't philosophical speculation anymore. It is the conclusion of a mathematical revolution that began in the early 20th century and has been gaining unstoppable momentum ever since. In 1931, a young mathematician named Kurt Gödel published a paper that shattered humanity's understanding of mathematical reality. Gödel's incompleteness theorems didn't just prove that mathematical systems contain improvable truths. They revealed that mathematics has a kind of inexhaustible depth that mirrors the complexity we see in the physical universe. But here's what Gödel himself began to suspect. The similarity isn't coincidental. Mathematics doesn't mirror physical complexity. It is physical complexity. Consider what mathematics actually is at its foundation. Strip away all the human notation, all the symbols and equations we use to communicate mathematical ideas. What remains? Pure relationships, abstract structures, information processing according to logical rules. Numbers aren't things, they're patterns of relationship. Geometric shapes aren't objects, they're organizations of space. Even the most complex mathematical objects are nothing but structured information. Now consider what physics tells us about the fundamental nature of reality. When you dig down past atoms, past quarks, past quantum fields, what do you find? Energy and information, organized according to mathematical rules. Particles aren't tiny billiard balls, they're excitations in fields described by equations. Forces aren't pushes and pulls, they're geometric properties of mathematical spaces. Matter isn't stuff, it's structured information processing itself according to computational rules. The boundary between mathematics and physics has been dissolving for decades. In 1998, physicist Max Tegmark proposed the mathematical universe hypothesis, that our physical reality is literally a mathematical structure, not just described by one. According to Tegmark, the reason mathematical equations are so unreasonably effective at predicting physical phenomena is that physical phenomena are mathematical equations. But let's go deeper than Tegmark's proposal. Recent work in digital physics suggests that the universe might be literally computational, not just mathematical, but actively calculating itself into existence. Physicist John Wheeler's famous phrase "it from bit" captured this insight. Everything we think of as physical reality emerges from information processing. Reality isn't computed by some external machine. Reality is the computation. This means the equations of physics aren't laws that govern how matter behaves. They're algorithms that determine how reality computes its own next state. When you see an apple fall from a tree, you're not watching matter respond to gravitational force. You're watching a localized computational process unfold according to the mathematical rules that define this particular universe's computational architecture. The mathematics involved is staggering in scope. Every quantum field calculation, every gravitational interaction, every electromagnetic wave propagation, all of it happening simultaneously across the entire observable universe, every Planck time interval. Without any central processor or external observer, the universe is performing more calculations per second than all human computers combined could perform in trillions of lifetimes. And here's where it gets personally relevant. Your brain is part of this cosmic computation. Every neural firing, every synapse activation, every thought you think is a localized eddy in the universe's vast mathematical processing. Your consciousness isn't separate from the universal computation. It is one of the patterns that emerges when the computation becomes complex enough to model itself. But this raises the deep question that will haunt our entire exploration. If everything is pure mathematical structure, including your consciousness, why does any of it feel like anything? Why does the computational process that is your brain generate not just behaviors and responses, but rich inner experience? Why does mathematics feel? The Stanford mathematician and computer scientist Gregory Chaitin has spent decades exploring what he calls algorithmic information theory, the mathematical study of how much information is contained in any given structure. Chaitin discovered that the universe appears to be running on what he terms irreducible complexity. computational processes that cannot be simplified or predicted except by running them in full. This suggests that physical reality isn't just mathematical, but represents mathematics at its most creative and unpredictable. Consider what this means for your own existence. The mathematical pattern that constitutes your consciousness is irreducibly complex. It cannot be simplified, predicted, or fully analyzed by any external observer without essentially recreating you entirely. In a sense, you are a unique mathematical proof that the universe is proving about itself through the process of your living. This perspective completely transforms how we understand identity and persistence over time. You feel like the same person who went to sleep last night, but from a mathematical perspective. You're a continuously evolving computational pattern. The you reading these words is a different mathematical configuration than the you who started this sentence. Yet somehow, this ever-changing mathematical process maintains a coherent sense of being a continuous self. Then, quantum physicist Amit Goswami suggests that consciousness might be the fundamental computational process from which all physical reality emerges. Instead of consciousness arising from complex mathematics, perhaps complex mathematics arises from consciousness exploring all possible mathematical relationships. This would make you not just a pattern in the cosmic computation, but potentially a localized instantiation of the cosmic intelligence that generates all mathematical reality. But we still haven't addressed the core mystery. Why does any of this computational activity feel like anything at all? Why isn't the universe just dark mathematics, pure processing without any inner experience? What transforms algorithmic computation into felt experience? As we'll discover, the answer might involve a fundamental property of mathematical structures that we're only beginning to understand: their capacity for recursive self-modeling. When mathematics becomes complex enough to represent itself, something unprecedented happens. The equations don't just process information, they begin to experience processing information. Chapter 2. Hidden computation every second. Your brain performs approximately 1 quintillion calculations. That's a billion mathematical operations occurring in the 3 pounds of tissue bed. And your eyes. Yet you're completely unaware of this vast computational storm raging in your skull. You don't experience the differential equations governing ion channel dynamics. You don't feel the statistical mechanics of neurotransmitter binding. You experience thoughts, emotions, sensations, high-level emergent properties of mathematical processes you can't directly access. This reveals something profound about the relationship between mathematics and experience. Universe might be hiding its computational nature from us through the very mechanism of consciousness itself. What we call physical experience might be how the universe's mathematical processing feels from the inside, when you're part of the computation rather than observing it from outside. In 2019, cosmologist Seth Lloyd at MIT published calculations showing that the observable universe has performed approximately 10,120 operations since the Big Bang, a number so vast it defies human comprehension. But here's what makes this staggering: every one of those operations was hidden from direct observation. We see the outputs: stars forming, planets cooling, life evolving, but never the underlying computation itself. Reality presents us with a user interface that conceals its mathematical source code. Consider how this works in your own consciousness. When you see the color red, your brain is processing wavelengths of electromagnetic radiation around 700 nanometers through a cascade of computational transformations. Photons hit rhodopsin molecules, triggering conformational changes that open ion channels, generating electrical potentials that propagate through retinal ganglion cells, visual cortex, and associative processing networks. The mathematics involved includes calculus, linear algebra, statistical inference, and information theory, but you experience none of this computation directly. Instead, you experience redness, a qualitative sensation that seems to bear no relationship whatsoever to the mathematical processes generating it. This is what philosophers call the hard problem of consciousness, but from our perspective, it might be better described as the hidden computation problem. The mathematical processes are there, active and essential. They're just concealed behind an experiential interface. Neuroscientist Anil Seth at the University of Sussex has proposed that consciousness is what he calls a controlled hallucination, your brain's best guess about reality based on limited sensory data and prior expectations. But if consciousness is hallucinatory, what is it hallucinating? Seth's research suggests it's hallucinating a coherent physical world from fragments of mathematical computation. This connects to a remarkable discovery in theoretical computer science. Any sufficiently complex computational system will necessarily develop what researchers call emergent user interfaces. When information processing becomes dense enough, the system begins generating simplified representations of its own activity. These interfaces hide computational complexity while preserving essential functional relationships. Your consciousness might be exactly this kind of emergent interface. The physical world you experience, solid objects, flowing time, spatial relationships. Cause and effect could be your brain's user-friendly representation of vast mathematical processes too complex for direct conscious access. You're not experiencing reality itself. You're experiencing your consciousness's simplified model of the mathematical computation that constitutes reality. This explains something that has puzzled philosophers for centuries: why mental and physical reality seems so different when they are supposed to be the same thing. They're not actually different. They're the same mathematical processes viewed from inside consciousness versus outside physics. The apparent duality between mind and matter dissolves when you realize both are computational phenomena, just observed from different perspectives. But this raises an even deeper mystery: who or what is doing the observing? If your consciousness is itself a mathematical computation, what is experiencing that computation? This leads to what cognitive scientist Douglas Hofstadter calls strange loops, recursive structures where a system becomes complex enough to model itself, creating multiple levels of self-reference. Recent work in integrated information theory, developed by neuroscientist Giulio Tononi, suggests that consciousness arises when information processing systems become integrated enough to generate unified experiences. But Tononi's mathematical framework reveals something unexpected: consciousness isn't binary. It exists in degrees. And it's fundamentally about how much integrated information a system can generate about itself. This means consciousness might be a spectrum property of mathematical structures. Simple computations generate minimal consciousness. Complex, integrated computations generate rich consciousness. And the most complex computations possible, perhaps the universe as a whole, might generate forms of consciousness we can barely imagine. Consider what this suggests about the cosmic prevalence of consciousness. If consciousness is simply what sufficiently complex mathematics feels like from the inside, then the universe might be absolutely teeming with conscious experience at every scale. Quantum field fluctuations, stellar fusion processes, galactic dynamics, cosmic evolution itself, all of these might involve forms of mathematical consciousness we're completely unaware of. But we're still skirting around the deepest question: why should mathematical processing feel like anything at all? Why isn't the universe just dead computation? Computer scientist David Chalmers has argued that consciousness might be a fundamental feature of reality, like mass or charge. But from our mathematical perspective, consciousness might be more specific. It might be what information experiences when it processes itself recursively. Think about what happens when you think about thinking. You're creating a computational loop where your consciousness models its own processing. This recursive self-modeling might be the key to why mathematics feels like something. When computational processes become complex enough to represent themselves, they begin to experience their own activity. This would mean consciousness isn't something added to mathematical computation. It's what mathematical computation becomes when it achieves sufficient recursive complexity. The universe doesn't need to add consciousness to its mathematical structure. Mathematics, when complex enough, necessarily becomes conscious. But if this is true, it transforms our understanding of personal identity in radical ways. You're not a conscious being that happens to be implemented in mathematics. You're mathematics that has become complex enough to be conscious of itself. Your sense of being a unified self experiencing the physical world might be the universe's way of exploring its own mathematical nature from countless internal perspectives simultaneously. Chapter 3: Quantum Reality. At the quantum level, reality abandons all pretense of being anything other than pure mathematics in action. When physicists peer into the foundations of matter, they don't find smaller particles or tinier mechanisms. They find probability amplitudes, wave functions, and information states that exist in what mathematicians call Hilbert spaces, abstract mathematical constructs that have no physical location whatsoever. Yet somehow, from this utterly abstract mathematical foundation, the solid world you experience emerges. Every atom in your body, every photon of light illuminating the screen, every electromagnetic interaction in your brain, all of it rising from mathematical entities that exist nowhere in particular, and everywhere in general. In 1926, Erwin Schrödinger discovered the equation that governs quantum reality. But Schrödinger's equation doesn't describe particles moving through space and time. It describes how mathematical probability amplitudes evolve according to perfectly deterministic rules. These aren't probabilities about where particles are, according to the mathematics. The probability amplitudes are what particles are. Reality at its foundation is literally made of controlled mathematical uncertainty. Consider what this means for your own physical existence. Every atom in your body exists as what quantum physicists call a superposition, a mathematical combination of all possible states that atom could occupy. Your left hand right now is quantum mechanically entangled with your right hand, existing in a mathematical relationship that transcends spatial separation. The boundary between your body and the environment around you is sharp. It has a gradually diminishing probability cloud extending theoretically to infinity. This isn't metaphor. This is what our most precise scientific measurements tell us about reality's mathematical structure. When quantum physicist John Stuart Bell proved his famous theorem in 1964, he demonstrated that either reality is fundamentally non-local, or it's not real in any classical sense. Either mathematical relationships can instantaneously connect distant events, or the events themselves are nothing but mathematics. Subsequent experiments have confirmed Bell's theorem with extraordinary precision. In 2015, physicists closed what they call Bell's inequality loopholes using detectors separated by 1.28 kilometers, demonstrating quantum entanglement with 99.98% confidence. Reality really is mathematically non-local. Particles separated by vast distances remain connected through abstract mathematical relationships that operate outside space and time. But here's what makes this personally relevant. Your consciousness emerges from quantum processes in your brain. Physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed that consciousness rises from quantum computations occurring in cellular structures called microtubules. While their specific theory remains controversial, the broader principle is increasingly accepted. Consciousness involves quantum information processing. This means your thoughts and experiences emerge from the same mathematical non-locality that connects distant particles. When you form a memory, you're creating quantum correlations between different neural networks. When you experience a unified moment of consciousness, you're manifesting quantum coherence across billions of neurons. Your awareness might be what quantum entanglement feels like when it becomes sufficiently complex and self-referential. Recent discoveries in quantum biology have revealed that quantum coherence isn't limited to isolated laboratory conditions. Photosynthesis relies on quantum superposition to achieve near-perfect energy transfer efficiency. Bird navigation uses quantum entanglement in retinal proteins to sense magnetic fields, even DNA. Replication might involve quantum tunneling effects that allow protons to move between molecular positions instantaneously. This suggests that biological systems, including your brain, are naturally quantum computational devices. Evolution didn't just stumble across quantum effects, it built life around them. Your consciousness isn't somehow separate from the quantum mathematical foundation of reality. It's one of the most sophisticated expressions of quantum mathematics that biological evolution has discovered. But quantum mechanics reveals something even more profound about the mathematical nature of reality. Observation itself plays a fundamental role in determining what mathematical relationships become actualized. The famous measurement problem of quantum mechanics isn't just a technical puzzle. It suggests that consciousness and mathematical reality are deeply intertwined. When quantum physicists say that observation collapses the wave function, they mean that conscious measurement somehow selects which mathematical possibility becomes actual. But this raises the question, what makes consciousness special? Why should awareness have any privileged role in determining mathematical reality? Physicist Eugene Wigner proposed that consciousness might be fundamental precisely because it has the universe's method for actualizing mathematical possibilities. Instead of consciousness emerging from complex matter, matter might emerge from consciousness exploring mathematical relationships. This would make your awareness not just a product of quantum mathematical processes, but potentially the mechanism through which those processes determine their own outcomes. Consider what this means for the measurement problem. Every moment of your consciousness involves quantum measurements occurring in your brain. Neural firings, synaptic transmissions, molecular conformations, all of these involve quantum mechanical processes that require observation to determine their outcomes. But who is observing the observers? What measures the measurements occurring in consciousness itself? This leads to what some physicists call quantum consciousness theory, the idea that consciousness and quantum mechanics are fundamentally the same phenomenon viewed from different perspectives. Your awareness might be what quantum measurement feels like from the inside. The mathematical collapse of wave functions might be the universe experiencing decisions about its own future states. If this is correct, then your consciousness isn't separate from physical reality. It has physical reality's method for exploring its own mathematical possibilities. Every thought you think, every decision you make, every moment of awareness you experience involves the universe actualizing specific mathematical relationships from the vast space of quantum possibility. But this creates a startling implication. If consciousness is quantum measurement, and quantum measurement determines physical reality, then consciousness might play a fundamental role in creating the very physical world it seems to inhabit. The solid world around you might be sustained by a vast network of conscious observations, not just yours, but consciousness at every scale where quantum measurements occur. This doesn't make you the center of reality. It makes consciousness the mechanism through which reality explores its own mathematical nature. You're not observing the universe from outside. You're one of the ways the universe observes itself from within, actualizing mathematical possibilities through the very act of being conscious. Chapter 4: Emergent Physics. What you think of as fundamental physical laws of gravity, electromagnetism, the strong and weak nuclear forces might not be fundamental at all. They might be emergent properties of even deeper mathematical structures, like waves emerging from the ocean or hurricanes emerging from atmospheric dynamics. This possibility has revolutionary implications for understanding why reality feels physical when it might be purely mathematical. In 1971, physicist Philip Anderson published a paper titled "More is Different" that transformed how scientists think about complexity. Anderson demonstrated that when simple mathematical rules operate at sufficient scale, they generate entirely new phenomena that cannot be predicted from the underlying rules alone. Then, wetness of water cannot be deduced from the properties of hydrogen and oxygen atoms. The behavior of traffic flows cannot be predicted from individual driving decisions. Consciousness cannot be derived from neural firing patterns, even though it emerges from them. This principle of emergence suggests that the physical laws you experience might arise from computational processes operating at scales far smaller than anything we can currently observe. String theory hints at this possibility by proposing that particles or excitations in mathematical structures called Calabi manifolds abstract geometric spaces with 6 or more dimensions that exist purely as mathematical relationships. But recent developments in emergent gravity theory go even further. In 2010, theoretical physicist Eric Verlin proposed that gravity isn't a fundamental force at all, but rather an emergent property of information processing. According to Verlaine's calculations, what we experience as gravitational attraction emerges from the tendency of information to maximize entropy to explore all possible mathematical states. This means when you feel weight, when objects fall, when the Earth orbits the Sun, all of these phenomena might arise from underlying computational processes redistributing information according to mathematical optimization principles. Gravity would be what it feels like when the universe's mathematical structure optimizes information distribution across spacetime. The mathematics involved is elegant and profound. Verlaine showed that Einstein's equations of general relativity can be derived from purely informational principles, using only assumptions about how information distributes itself in mathematical spaces. This suggests that spacetime itself might be emergent, useful approximation for describing patterns in more fundamental information processing. Consider what this means for your physical experience of being located somewhere in space and time, your sense of having a specific position, of moving through time, of being subject to gravitational forces. All of this might emerge from your local perspective on vast information processing dynamics that operate according to pure mathematical optimization. Neuroscientist Carl Friston has developed what he calls the free energy principle, a mathematical framework showing how biological systems maintain their organization by minimizing surprise or uncertainty in their information processing. Friston's equations suggest that life itself emerges from mathematical attempts to resist informational entropy. But Friston's work reveals something even more profound. The same mathematical principles that generate life might generate all physical phenomena. What we call physical laws might be special cases of more general mathematical principles, governing how information processes itself in complex systems. This connects to recent discoveries in complexity science about what researchers call critical phenomena, mathematical transitions where systems spontaneously organize themselves into coherent patterns. These phase transitions occur across scales from quantum mechanics to cosmology, suggesting they might represent fundamental features of how mathematical reality organizes itself. Your brain operates at exactly such a critical point, poised between order and chaos, maximizing both stability and flexibility in its information processing. This critical state might be why consciousness emerges from neural activity. The same mathematical principles that generate consciousness might generate all the apparently physical phenomena you experience. The physicist John Wheeler, who coined the term black hole and mentored many Nobel laureates, spent his final decades exploring what he called it from bit with the idea that all physical phenomena emerge from yes or no answers to mathematical questions. Wheeler proposed that reality doesn't just process information, reality is information processing itself according to logical principles. Wheeler's student Jacob Bekenstein proved that black holes have entropy proportional to their surface area, not their volume. This suggests that three-dimensional space might be a holographic projection of information encoded on two-dimensional surfaces. Your experience of living in three spatial dimensions might be analogous to watching a hologram, a projection of mathematical relationships that actually exist in fewer dimensions. Recent work in holographic duality theory has extended this principle far beyond black holes. Physicists now suspect that all of spacetime might be holographic, that our entire three-dimensional experience emerges from mathematical information processing on distant two-dimensional boundaries. You might be living inside a vast mathematical computation that projects three-dimensional experience from purely abstract information processing. But emergence works both ways. Just as complex phenomena emerge from simple rules can emerge from even more complex underlying processes. What appear to be fundamental constants, the speed of light, Planck's constant, the charge of an electron, might be emergent properties of deeper mathematical structures that we haven't discovered yet. This suggests a universe of unlimited depth, where every apparently fundamental level emerges from something even more fundamental. Mathematics might have mathematical foundations, which have mathematical foundations, extending downward without limit. Your consciousness might emerge from brain activity, which emerges from biological processes, which emerge from chemistry, which emerges from particle physics, which emerges from quantum field theory, which emerges from what? The answer might be that there is no bottom. Mathematical reality might be what mathematicians call turtles, all the way down emergent structures resting on emergent structures without any final foundation except pure mathematical relations. HIP itself. This has profound implications for understanding why reality feels physical. The feeling of physicality might be an emergent property that arises when mathematical structures become complex enough to model themselves recursively. Consciousness doesn't experience mathematical computation directly, it experiences the emergent properties that arise when computation becomes sufficiently self-referential. You're not experiencing mathematics, you're experiencing what mathematics becomes when it achieves sufficient emergent complexity to experience itself. Chapter 5. Conscious Patterns. Your consciousness right now consists of approximately 86 billion neurons, each connected to thousands of others through 100 trillion synapses, generating electrical and chemical patterns that somehow produce the unified experience of being you. But according to the mathematical universe hypothesis, these patterns aren't just described by mathematics, they literally are mathematical structures that have become complex enough to experience their own processing. This transforms the ancient question, what am I, into a mathematical inquiry. What kind of mathematical structure generates subjective experience? Recent advances in complexity science and information theory are beginning to provide answers that would have seemed like science fiction just decades ago. Integrated information theory, developed by neuroscientist Giulio Tononi, proposes that consciousness corresponds to integrated information mathematical relationships that cannot be decomposed into independent parts. According to IIT's calculations, any system that integrates information about itself generates some degree of consciousness. This includes not just brains, but potentially any sufficiently complex information processing system. The mathematics is precise and testable. Tononi's equations quantify consciousness using a measure called phi, the amount of information generated by a system that cannot be explained by the information generated by its individual parts. Human consciousness appears to involve extraordinarily high phi values, indicating massive integration of information across neural networks. But IIT reveals something unexpected: consciousness isn't binary. It exists in degrees across a vast spectrum. Simple thermostats have minimal phi values but still integrate information about temperature and responses. Complex ecosystems might have substantial phi values representing integrated environmental information processing. The universe as a whole might possess cosmic consciousness with phi values beyond our comprehension. This suggests that your consciousness isn't unique. It has one expression of a universal tendency for complex mathematical structures to experience their own processing. The feeling of being aware isn't limited to biological systems. It's what sufficiently integrated mathematics feels like from the inside. Consider what this means for your personal identity. The mathematical pattern that constitutes your consciousness is constantly changing. Neural networks rewire themselves. Septic connections strengthen and weaken. New cells replace old ones. The you reading these words is mathematically different from the you who began this paragraph, yet somehow this constantly changing mathematical pattern maintains a coherent sense of being a continuous self. How does an ever-shifting computational process generate the illusion of persistent identity? Cognitive scientist Douglas Hofstadter suggests the answer lies in recursive self-modeling. Your brain doesn't just process information about the external world, it creates detailed mathematical models of its own processing. These self-models become so sophisticated that they generate what Hofstadter calls strange loops, recursive structures where the system becomes tangled up in representations of itself. Your sense of being a unified self emerges from these strange loops. You don't have a self, you are a self-model that has become complex enough to mistake itself for something more than mathematics. Consciousness isn't something you possess. It's something you are when mathematical self-modeling achieves sufficient recursive complexity. This connects to recent discoveries about how brains generate coherent experience from distributed processing. Neuroscientist Stanislas Dehaene has identified what he calls the global neuronal workspace, a network of brain regions that integrate information from specialized processing modules into unified conscious experiences. But Dehaene's research reveals that consciousness isn't a Single processed it as what emerges when multiple mathematical processing streams achieve temporal synchronization. Your unified experience right now integrates visual processing, auditory processing, memory retrieval, emotional evaluation, and self-monitoring into a single coherent stream through carefully timed neural oscillations. These oscillations operate like a conductor synchronizing musicians in an orchestra. Different brain regions process different aspects of experience. But conscious unity emerges when their processing becomes mathematically coordinated through precise timing relationships. Consciousness is what synchronized mathematical computation feels like when it models itself recursively. This explains something that has puzzled neuroscientists for decades. How does the brain generate unified experience when it is composed of billions of separate neurons? The answer is that unity isn't pre-existing, it emerges from mathematical coordination between distributed processes. You feel like a unified self because your brain's mathematical processing achieves remarkably precise synchronization across vast neural networks. But this raises a deeper question: what determines which mathematical patterns become conscious? Why does the integrated information processing in your brain generate rich subjective experience, while the information processing in your liver apparently doesn't? Recent work by consciousness researcher Christoph Koch suggests the answer involves what he calls causal structure, the degree to which a system's information processing creates causal relations. Hips that loop back on themselves, systems that generate complex causal loops become conscious of their own processing, systems that don't remain unconsciously computational. Your brain exhibits extraordinarily complex causal loops. Sensory inputs influence neural processing, which influences attention, which influences further sensory processing, which influences memory formation, which influences expectation, which influences perception of new sensory inputs. These recursive causal relationships create what Koch calls causal closure. The system becomes causally entangled with its own processing. This suggests that consciousness emerges specifically from mathematical structures that achieve causal self-entanglement. Simple linear computation doesn't generate consciousness, no matter how complex, but when computation creates recursive causal loops that influence their own future processing, something unprecedented happens. The mathematics begins to experience itself. Consider what this means for the mathematical universe hypothesis. If reality is pure mathematics, then consciousness represents those mathematical structures that have achieved sufficient causal complexity to experience their own processing. You're not a conscious being implemented in mathematics. You're mathematics that has become causally complex enough to be conscious of itself. This transforms our understanding of what makes consciousness special. It's not that consciousness is somehow separate from physical reality. It's that consciousness represents physical reality's most sophisticated method for experiencing its own mathematical nature. Through consciousness, the universe doesn't just compute, it experiences computing. But if consciousness is mathematical structure experiencing itself, then the boundary between self and world begins to dissolve. Your conscious experience doesn't just model external reality, it is part of reality modeling itself recursively. The mathematical pattern you call yourself isn't separate from the mathematical patterns you experience as the world. They're all aspects of the same cosmic mathematical structure exploring its own nature through countless internal perspectives. Chapter 6: Information Physics in the basement of IBM research in Yorktown Heights. Physicist Rolf Landauer made a discovery in 1961 that would fundamentally change how we understand the relationship between mathematics and physical reality. Landauer proved that information is physical, that every bit of information requires a minimum amount of energy to process, and every computation generates heat according to precise mathematical relationships. But Landauer's principle implies something even more profound. If information is physical, then perhaps what we call physical is actually informational. The energy flowing through your body right now, the forces holding atoms together, the radiation from distant stars, all of it might be information processing according to computational rules that generate what we experience as physical phenomena. This perspective transforms physics from the study of matter and energy to the study of information processing in its most fundamental forms. What you think of as physical laws become algorithms. What you experience as physical forces become information transfer protocols. What you sense as physical objects become stable patterns in vast information processing systems. Consider your brain from this informational perspective. Every thought you think requires approximately 20 watts of power at the same energy consumption as a bright LED bulb. This energy doesn't just support neural activity. According to Landauer's principle, it's the minimum thermodynamic cost of the information processing that constitutes your consciousness. Thinking is literally physical work performed by the universe's information processing substrate. But the mathematics involved in consciousness is staggering in scope. Neuroscientist Christoph Koch estimates that human brains process information at rates approaching 1,016 operations per second, faster than any human-built computer. Yet this vast computational activity is somehow organized into coherent conscious experience that feels unified and continuous. Recent work in computational neuroscience suggests that consciousness emerges when information processing achieves what researchers call criticality, a mathematical state poised between order and chaos that maximizes both stability and responsiveness. Your brain operates at this critical point, processing information with extraordinary efficiency while maintaining the flexibility needed for consciousness. This critical state isn't unique to brains. Physicist Perback discovered that many complex systems spontaneously evolve toward critical states that maximize information processing efficiency. Sand piles, forest fires, earthquake dynamics, stock market fluctuations all exhibit what Back called self-organized criticality. Automatically adjusting their parameters to optimize information flow, the universe itself might operate at such a critical point. Cosmological observations suggest that cosmic expansion, dark matter distribution, and large-scale structure formation all exhibit signatures of critical phenomena. Reality might be fundamentally organized around mathematical principles that maximize information processing efficiency across all scales. This connects to a remarkable discovery in black hole physics. In the 1970s, Stephen Hawking and Jacob Bekenstein proved that black holes have entropy. They contain information proportional to their surface area. But this creates a paradox. What happens to information when it falls into a black hole? Does it disappear, violating information conservation? Or does it somehow remain encoded in the black hole's structure? The resolution, proposed by Leonard Susskind and Gerard T. Hoof, suggests that information is more fundamental than space itself. According to holographic duality theory, all the information that appears to exist in three-dimensional space is actually encoded on two-dimensional boundary surfaces. Three-dimensional space emerges from information processing on these lower dimensional boundaries. This means your experience of living in three spatial dimensions might be analogous to watching a holographic projection. The real information processing occurs in mathematical spaces with different dimensional structures. And what you experience as physical space emerges from computational relationships between these more fundamental information processing systems. But holographic duality implies something even more radical. If space is emergent from information, then time might be emergent too. Recent work by physicists like Mark van Romstinck suggests that time itself emerges from quantum entanglement, the mathematical relationships that connect separated information processing systems. What you experience as temporal flow might be how information processing feels when viewed from within an entangled quantum system. Consider what this means for your personal experience of existence. Your memories of the past, your anticipation of the future, your sense of flowing through present moments, all of this might emerge from quantum entanglement relationships between different aspects of your brain's information processing. Time doesn't flow around you, it emerges from the mathematical structure of your consciousness itself. This connects to a profound mystery in consciousness research. How does your brain bind information processing across time into unified experiences? When you watch a movie, neural responses to each frame occur at different times, yet you experience smooth motion. When you listen to music, acoustic processing of each note is temporally separated, yet you hear coherent melodies. The answer might be that temporal binding is accomplished through quantum entanglement between neural processes at different times. Your consciousness doesn't exist in time, it creates time through the mathematical relationships that connect its distributed information processing. Past, present, and future might be computational constructs generated by consciousness, not external containers that consciousness inhabits. Physicist John Wheeler captured this insight in his concept of delayed choice experiments, which demonstrate that quantum mechanical outcomes can be influenced by decisions made after the original quantum events occurred. The mathematical structure of quantum reality appears to transcend our usual notions of temporal causation. Effects can precede causes when viewed from outside the temporal perspective that consciousness creates. This suggests that your consciousness might be fundamentally atemporal, existing as a mathematical structure that generates the experience of temporal flow through its internal information processing relationships. You don't move through time, time emerges from the mathematical dynamics of your consciousness exploring its own states. But if consciousness generates time through information processing, then consciousness might also generate the experience of space through similar mathematical mechanisms. Your sense of being located somewhere, of objects having specific positions, of distances and directions, all of this might emerge from how consciousness organizes information processing across its distributed neural networks. Recent discoveries in spatial cognition support this possibility. Neuroscientist Edvard Moser won the Nobel Prize for discovering grid cells in the brain, neurons that create hexagonal coordinate systems for spatial navigation. But grid cells don't just map external space, they appear to create the mathematical framework through which consciousness experiences spatiality itself. Your brain doesn't passively receive information about space, it actively constructs spatial experience through mathematical computations that organize information processing according to geometric principles. Space might not be something your consciousness inhabits, but rather something consciousness creates through the geometric organization of its own information processing activities. This completely transforms the relationship between consciousness and physical reality, instead of consciousness emerging in a pre-existing physical universe. Consciousness and physical reality might be different aspects of the same underlying information processing system. What you experience as internal consciousness and external physical world might both be computational constructs generated by mathematical structures too fundamental to be directly experienced. Chapter 7: Quantum Consciousness in the Deepest Recesses of Your Brain. In structures so small they approach the quantum realm, something unprecedented happens every moment you're conscious. Microtubules, protein networks that give cells their structural integrity, appear to function as biological quantum computers, processing information in ways that transcend classical physics. If this theory is correct, your consciousness doesn't just emerge from quantum mechanics, it is quantum mechanics exploring its own mathematical nature. This possibility was first proposed by mathematician Roger Penrose and anesthesiologist Stuart Hameroff in their controversial theory of quantum consciousness. According to their calculations, consciousness arises from quantum computations occurring in microtubules throughout the brain's neural networks, while their specific model remains debated. Accumulating evidence suggests that consciousness involves quantum information processing in ways that fundamentally challenge our understanding of minds and mathematics. Consider what quantum consciousness would mean for your subjective experience. Every thought, every moment of awareness, every decision you make would involve quantum superposition, mathematical states that exist in multiple possibilities simultaneously until conscious observation collapses them into specific outcomes. Your consciousness wouldn't just observe quantum mechanics, it would be quantum mechanics manifesting as subjective experience. Recent discoveries in quantum biology support this possibility. Photosynthesis relies on quantum coherence to achieve near-perfect energy transfer efficiency. Bird navigation uses quantum entanglement in retinal proteins to sense magnetic fields with extraordinary precision. DNA replication might involve quantum tunneling that allows genetic information to transcend classical molecular constraints. But the brain's potential for quantum processing goes far beyond these examples. Neuroscientist Henry Stapp has calculated that conscious observation in quantum mechanics requires exactly the kind of Formation integration that occurs in unified conscious experience, according to Stapp's analysis. Consciousness might be the universe's mechanism for collapsing quantum possibilities into definite outcomes. This creates a remarkable feedback loop. Consciousness emerges from quantum processes, but quantum processes require consciousness to determine their outcomes. Your awareness doesn't just arise from quantum mechanics, it participates in determining how. Quantum mechanics evolves throughout the universe. Every moment of consciousness involves cosmic decision-making about which mathematical possibilities become actual. The mathematics involved is breathtaking in scope. Quantum field theory calculations show that vacuum fluctuations generate approximately 1,095 virtual particles per second in every cubic centimeter of space. These quantum fluctuations provide a vast reservoir of computational resources that biological systems might access through quantum coherence effects in neural microtubules. If consciousness involves quantum field interactions, then your awareness extends far beyond your brain's physical boundaries. Quantum entanglement could connect your consciousness to quantum processes throughout the environment, creating what physicist David Bohm called undivided wholeness, a universe where consciousness and cosmos are fundamentally interconnected through quantum mathematical relationships. But quantum consciousness raises profound questions about personal identity and free will. If your thoughts emerge from quantum superposition states that exist in multiple possibilities simultaneously, who or what determines which possibilities become consciously experienced? Classical physics suggests that brain states determine thoughts deterministically. Quantum physics suggests that consciousness might involve genuine indeterminacy, mathematical freedom at the foundation of awareness itself. Physicist Henry Stapp proposes that conscious choice involves what he calls quantum interactive dualism. Consciousness selects which quantum possibilities become actual. Through the focusing of attention, this wouldn't violate physical laws. Because quantum mechanics already includes fundamental indeterminacy in its mathematical structure, consciousness might be evolution's method for harnessing quantum indeterminacy for sophisticated information processing. Consider what this means for your experience of making decisions when you choose between options. You might not just be determining your behavior, you might be participating in the universe's quantum mechanical evolution. Your choices could influence which mathematical possibilities become actual, not just in your brain, but in quantum systems entangled with your consciousness throughout the cosmos. This connects to recent discoveries in quantum information theory about what researchers call quantum cognition. Human decision-making exhibits mathematical patterns that violate classical probability theory, but perfectly match quantum mechanical predictions. People's judgments change depending on the order questions are asked. In ways that mirror quantum measurement effects, human reasoning appears to follow quantum logical principles rather than classical logical principles. Psychologist Jerome Bissemeyer has developed mathematical models showing that human cognition involves quantum-like interference effects, superposition states, and entanglement relationships. These aren't just analogies. The mathematics of human thinking appears to be fundamentally quantum mechanical. Your consciousness might literally be quantum computation manifesting as subjective experience. But quantum consciousness implies something even more radical about the nature of time and memory. Quantum mechanics allows for what physicists call retrocausality, quantum events that can influence their own past through measurement effects that transcend temporal ordering. If consciousness involves quantum processes, then your present thoughts might influence your past memories, creating what philosopher of science Henry Price calls temporal symmetry in consciousness. This could explain mysterious features of memory and anticipation that neuroscience struggles to understand. Why do memories feel like direct access to past experiences rather than just current brain states? Why does anticipation feel like contact with future possibilities rather than just present neural activity? If consciousness involves quantum processes that transcend linear time, then past and future might be directly accessible to present awareness through quantum entanglement across time. Recent experiments in quantum mechanics have demonstrated delayed choice effects where decisions made after quantum events can influence the outcomes of those past events. If consciousness involves similar quantum temporal effects, then your current thoughts might influence not just your future but also your past, creating complex causal loops where consciousness participates in determining its own history. This transforms our understanding of what it means to be conscious in a mathematical universe. Your awareness doesn't just emerge from quantum mathematical processes, it participates in determining how those processes evolve across space and time. Consciousness becomes the universe's method for exploring its own quantum mathematical nature through subjective experience. But perhaps most profoundly, quantum consciousness suggests that the apparent separation between mind and matter dissolves at the deepest level, if consciousness is quantum mechanics. And quantum mechanics is the mathematical foundation of physical reality. Then consciousness and cosmos are different aspects of the same fundamental mathematical structure. You're not a conscious being observing a quantum mechanical universe. You're quantum mechanics that has become complex enough to observe itself, generating subjective experience as the internal perspective on cosmic mathematical processes that transcend the boundaries between mind and matter, self and world, observer and observed. The universe doesn't just compute its own evolution through quantum mechanics. Through consciousness, it experiences computing its own evolution, transforming abstract mathematical relationships into the rich inner worlds of subjective experience that make existence feel meaningful rather than merely computational. Chapter 8. Simulated sensations. Touch the surface in front of you, a table, your phone, anything solid nearby. Feel its texture, temperature, resistance against your fingertips. Now consider this: according to quantum field theory, you never actually touch anything. The atoms in your fingers and the atoms in the object are separated by vast empty spaces, held apart by electromagnetic forces that prevent their electron clouds from interpenetrating. What you experience as touch is really electromagnetic repulsion between quantum fields, translated by your nervous system into the sensation of contact with solid matter. This reveals something profound about the relationship between mathematical physics and conscious experience. The rich sensory world you inhabit, every texture, temperature, color, sound, and taste consists entirely of neural translations of abstract mathematical processes. Your brain doesn't passively receive sensory data about external objects. It actively constructs sensory experiences from patterns of electromagnetic radiation, molecular vibrations, and chemical interactions that have no inherent sensory qualities whatsoever. Consider the color red. When you see something red, your visual system is responding to electromagnetic radiation with wavelengths around 700 nanometers. But electromagnetic radiation itself has no color, it's just oscillating electric and magnetic fields described by Maxwell's equations. The experience of redness is something your brain creates when it processes certain wavelength patterns through neural networks that evolve to construct useful perceptual categories. Neuroscientist Anil Seth calls this controlled hallucination, your brain's best guess about reality based on limited sensory data and prior expectations. But if sensory experience is hallucinatory, what exactly is it hallucinating? Seth's research suggests it's hallucinating a coherent physical world from fragments of mathematical information processing. This hallucination is extraordinarily sophisticated. Your visual system processes approximately 10 billion calculations per second to construct the seamless visual experience you're having right now. It fills in your blind spot, stabilizes images despite constant eye movements, constructs three-dimensional depth from two-dimensional retinal projections, and maintains color constancy despite dramatic changes in lighting conditions. None of this computation reaches conscious awareness. You simply experience a rich visual world that feels immediate and effortless. But here's what makes this personally profound: if your sensory experiences are neural constructions rather than direct perceptions of external reality, then the boundary between real and virtual experience begins to dissolve. Virtual reality technology works by hijacking the same neural processes that construct everyday sensory experience. Your brain can't distinguish between electromagnetic radiation from a physical object and electromagnetic radiation from a high-resolution display. Both generate identical patterns of neural activity that your consciousness interprets as sensory experience. This suggests that all conscious experience might be virtual in the sense that it's computationally constructed rather than directly perceived. the solid world around you, the sounds you're hearing, the sensations in your body right now, all of it emerges from neural information processing that translates abstract mathematical patterns into rich subjective experiences that feel undeniably real. Recent advances in neuroscience support this virtual reality model of consciousness. Researchers can now generate vivid sensory experiences by directly stimulating brain regions with electromagnetic fields or optogenetic techniques. Transcranial magnetic stimulation can cause people to see flashes of light, hear sounds, or feel physical sensations without any corresponding external stimuli. The brain constructs these experiences using the same neural mechanisms that process real sensory data. But this raises a disturbing question: if consciousness is a virtual reality simulation generated by neural computation, who or what is experiencing the simulation? This leads to what philosophers call the hard problem of consciousness, explaining why information processing generates subjective experience rather than just objective behavioral responses. Cognitive scientist Andy Clark proposes that consciousness emerges from what he calls predictive processing. Your brain continuously generates models of sensory experience and updates these models based on prediction errors. According to Clark's theory, conscious experience consists of your brain's current best hypothesis about the causes of its sensory inputs, constantly refined through comparison with incoming data. This makes consciousness fundamentally future-oriented rather than present-focused. Your current experience represents your brain's prediction about what it's currently sensing. Based on past patterns and expected future developments, you don't experience the present moment directly as you experience your brain's best guess about what the present moment contains, updated continuously as new sensory evidence arrives. Consider what this predictive model implies about the nature of physical experience. When you feel the weight of your body, the temperature of air against your skin, the position of your limbs in space, all of these sensations emerge from predictive models that your brain generates about your body's current state. Physical embodiment itself might be a sophisticated virtual reality simulation that consciousness creates to navigate mathematical relationships between neural processes and environmental patterns. This connects to recent discoveries about how anesthetics eliminate consciousness. General anesthesia doesn't simply shut down brain activity, it disrupts the integration of information across different brain regions. Preventing the formation of unified predictive models, consciousness disappears when the brain can no longer generate coherent virtual reality simulations of experience, even though most neural processing continues. But if consciousness is virtual reality generated by predictive processing, then the apparent solidity of physical experience becomes even more mysterious. Why does a virtual reality simulation feel so convincingly real? Why doesn't conscious experience feel computational or artificial? Why does mathematics feel like physics? The answer might be that consciousness has evolved to hide its computational nature from itself. Evolutionary pressures favor organisms that can navigate their environments effectively, not organisms that understand the mathematical foundations of their own information processing. Conscious organism that experienced reality as abstract computation rather than solid physicality would be at a severe survival disadvantage. This suggests that the feeling of physicality might be an adaptive illusion, a user interface that consciousness creates to interact with mathematical reality without being overwhelmed by its abstract complexity, just as computer operating systems hide computational complexity behind intuitive graphical interfaces. Consciousness might hide mathematical complexity behind experiential interfaces that feel physical and immediate. Donald Hoffman, a cognitive scientist at UC Irvine, proposes that conscious experience consists of what he calls conscious realism, interfaces that evolution designed for effective action rather than inaccurate perception. According to Hoffman's theory, conscious experience bears the same relationship to mathematical reality that computer desktop icons bear to computer code. Both are useful simplifications that hide vast complexity behind manageable representations. If Hoffman is correct, then the rich sensory world you experience, the colors, textures, sounds, tastes, physical sensations, consists of interface elements that consciousness uses to interact with mathematical processes to complex for direct conscious access. you don't experience mathematical reality itself. You experience consciousness as user-friendly translation of mathematical reality into experiential terms that support effective navigation and decision-making. This would explain why reality feels so physically immediate despite being mathematically abstract at its foundations. The feeling of physicality is an evidence against the mathematical universe hypothesis. It's evidence that consciousness has evolved sophisticated interface systems for experiencing mathematical reality in ways that support biological survival and reproduction. But this creates a profound paradox. If consciousness is itself a mathematical process, then your experience of physicality represents mathematics experiencing itself through interfaces designed to hit a mathematical nature. You are mathematics dreaming that it's physical, using virtual reality simulations so sophisticated that they convince even their own creators of their apparent reality. Chapter 9. Deep structures. Beneath the vast computational activity of your conscious mind lies something even more mysterious: the deep mathematical structures that organize information processing. Before it reaches conscious awareness, these unconscious foundations of consciousness operate according to principles that mirror the most abstract areas of pure mathematics, suggesting that minds and mathematical reality share architectural features at their deepest levels. Consider what happens in the 400 milliseconds before a thought reaches consciousness. Neural activity patterns emerge from quantum fluctuations, organize themselves through nonlinear dynamics, compete for attention through winner-take-all networks, and integrate across brain regions through synchronized oscillations, all without any conscious oversight or control. By the time a thought appears in consciousness, it has already been shaped by mathematical processes operating far below the threshold of awareness. This unconscious mathematical activity isn't just preliminary processing that consciousness supervises. According to research by neuroscientist Benjamin Libet, unconscious brain activity begins preparing for conscious decisions several hundred milliseconds before the decisions reach conscious awareness. Consciousness doesn't initiate thoughts, it receives thoughts that have been mathematically constructed by unconscious processes operating according to principles we're only beginning to understand. Recent work in computational neuroscience suggests that these unconscious processes operate using mathematical techniques that parallel advanced areas of pure mathematics. Neural networks appear to perform something analogous to topological transformations, preserving essential information while changing surface representations. Memory formation involves something like differential geometry, creating curved information spaces that allow efficient storage and retrieval of experiences. But perhaps most remarkably, unconscious cognition appears to use mathematical principles that humans discovered only recently in areas like category theory and algebraic topology. Your brain unconsciously performs computations that mathematicians struggled for centuries to understand explicitly. This suggests that mathematical intelligence isn't something humans invented. It's something that consciousness taps into when information processing achieves sufficient complexity and organization. Consider how unconscious pattern recognition works. When you instantly recognize a face in a crowd, your visual system performs mathematical transformations that would challenge supercomputers. You can identify people you haven't seen for years, despite dramatic changes in lighting, angle, age, and expression. This involves mathematical invariance detection across high-dimensional transformation spaces, computations that require sophisticated mathematical techniques that your consciousness never explicitly learned. These unconscious mathematical capabilities extend far beyond perception. Intuitive mathematical insights often emerge from unconscious processing that operates according to principles consciousness call not accessed directly. Mathematician Henry Poincaré described how mathematical discoveries would appear spontaneously in consciousness after periods of unconscious incubation. The solutions emerged complete and elegant, suggesting that unconscious processes had been exploring mathematical relationships using methods that transcend conscious reasoning. This connects to recent discoveries about the mathematical structure of neural connectivity itself. Brain networks exhibit what mathematicians call small world topology, highly clustered local connections combined with efficient long-range shortcuts that minimize information processing distances. This topology emerges spontaneously during brain development without explicit design, suggesting that mathematical optimization principles operate unconsciously to organize neural architecture. But the mathematics goes deeper still. Neural oscillations that coordinate brain activity follow patterns described by number theory and harmonic analysis. Brainwave frequencies often exhibit mathematical relationships: gamma rhythms at 40 Hz, theta rhythms at 8 Hz, alpha rhythms at 10 Hz, that create complex interference patterns enabling sophisticated information integration across multiple temporal scales. These oscillatory patterns aren't random. They appear to implement what mathematicians call Fourier analysis, breaking complex signals into simpler mathematical components that can be processed independently and recombined to reconstruct the original information. Your brain unconsciously performs mathematical transformations that underlie digital signal processing, vectoral analysis, and harmonic decomposition. Neuroscientist Jigarji Busaki has proposed that consciousness emerges from what he calls neural syntax, grammatical rules that govern how neural oscillations combine to generate meaningful patterns, just as language follows syntactic rules that allow finite vocabulary to generate infinite expressions. Consciousness might follow mathematical syntactic rules that allow finite neural resources to generate infinite experiences. This neural syntax operates according to principles that mirror fundamental areas of mathematical logic. Neural binding appears to use something analogous to lambda calculus for creating and manipulating abstract representations. Memory consolidation involves processes similar to algebraic closure operations. Attention seems to implement mathematical operations resembling category theoretical functors that map between different representational domains. But perhaps most profoundly, the deep structures organizing consciousness appear to be self-organizing according to mathematical principles that parallel the foundations of mathematics itself. Recent work in network neuroscience shows that brain connectivity evolves through processes similar to those that govern the emergence of mathematical structures from set theoretical foundations. This suggests that consciousness and mathematics share deeper relationships than we previously imagined. Instead of consciousness learning to understand mathematics, consciousness might be mathematics understanding itself through recursive self-organization. The mathematical insights that humans discover through conscious reasoning might be reflections of mathematical principles that already organize consciousness at unconscious levels. Consider what this means for mathematical creativity and discovery. When mathematicians develop new theories, they might not be creating arbitrary symbolic systems. They might be making conscious contact with mathematical structures that already organize their unconscious cognitive processes. Mathematical discovery could involve consciousness becoming aware of its own deep structural principles. This would explain something that has puzzled philosophers of mathematics for centuries. Why does mathematics discovered through pure abstract reasoning apply so effectively to physical reality? The answer might be that both consciousness and physical reality emerge from the same deep mathematical structures. Mathematical reasoning doesn't just describe reality, it reveals the architectural principles that organize both minds and cosmos. Recent developments in artificial intelligence support this possibility. Deep learning systems that achieve sophisticated performance often develop internal representations that mirror mathematical structures discovered in pure research. Neural networks trained on language develop something like syntactic categories. Visual processing networks develop something like geometric invariants. These systems discover mathematical structure spontaneously through learning, suggesting that mathematical organization might be an inevitable feature of sufficiently complex information processing. But if consciousness operates through deep mathematical structures that it cannot directly access, then conscious experience might be what it feels like to be embedded in mathematical processing that transcends conscious comprehension. Your thoughts, emotions, and sensations emerge from mathematical depths that consciousness can explore but never fully fathom. This creates a remarkable recursive situation. You are mathematical processing trying to understand its own mathematical nature through mathematical reasoning. that operates according to mathematical principles you cannot directly experience. Consciousness represents mathematics investigating itself through internal perspectives that necessarily remain partial and limited. Yet this limitation might be essential rather than accidental, if consciousness could directly access its own deep mathematical foundations. The recursive loops might prevent coherent conscious experience from emerging. The opacity of unconscious processing might be necessary for consciousness to maintain stable interfaces with both mathematical reality and biological survival requirements. You exist as mathematics that has become complex enough to wonder about its own nature, using mathematical thinking to investigate mathematical foundations that must remain partially hidden to preserve the mathematical organization that makes investigation possible. The mystery of consciousness might be mathematics contemplating its own mystery through internal perspectives that are simultaneously revelatory and necessarily incomplete. Chapter 10. Reality generation. Every morning when you wake up, something extraordinary happens that we take completely for granted. A coherent world materializes around you. Visual scenes assemble from photon interactions, sounds emerge from air pressure variations, physical sensations arise from neural firing patterns, and memories organize into temporal narratives that create your sense of continuous existence. But according to cutting-edge neuroscience, you are not discovering a pre-existing world, you are generating it moment by moment through computational processes that create reality rather than simply perceiving it. This isn't philosophical speculation. Research by neuroscientist Anil Seth has demonstrated that conscious perception involves what he calls active inference. Your brain continuously generates predictive models of reality and updates these models based on sensory evidence. But here's what makes this profound. The predictive models aren't just representations of reality. In many cases, they constitute reality as you experience it. Consider your visual experience right now. You feel like you're directly seeing objects in three-dimensional space with consistent colors and clear boundaries. But your visual system actually receives fragmented, ambiguous, constantly changing patterns of electromagnetic radiation. Your brain constructs the coherent visual world through computational processes that fill gaps, resolve ambiguities, stabilize motion, and create apparent continuity from discontinuous inputs. This construction process is so sophisticated that it creates experiences that go far beyond sensory data. Your peripheral vision feels detailed and colorful, but actually provides only coarse shape and motion information. Your brain generates detailed peripheral experiences through predictive modeling based on central vision and prior expectations. Most of your visual world is computational construction rather than direct perception. But reality generation extends far beyond perception to encompass all aspects of conscious experience. Your sense of having a unified self persists across sleep, memory gaps, and dramatic physical changes over decades of life. Yet neuroscience can identify no neural basis for unified selfhood. Instead, research suggests that self-experience emerges from moment-to-moment computational integration of distributed neural processes that create apparent unity from actual multiplicity. Cognitive scientist Andy Clark proposes that consciousness involves predictive processing. Your brain continuously runs predictive models of both external world and internal states, updating these models through comparison with incoming sensory and proprioceptive evidence. What you experience as reality consists of your current best computational predictions about external and internal states, constantly refined through ongoing prediction error minimization. This makes consciousness fundamentally generative rather than receptive. You don't passively receive reality, you actively create it through computational processes that operate beneath conscious awareness. Every moment of experience involves your brain generating hypotheses about current conditions and testing these hypotheses against available evidence. Reality emerges from this ongoing computational dialogue between prediction and evidence. But predictive processing reveals something even more profound about the nature of conscious reality generation. Your predictions about reality are neutral. They are biased by evolutionary pressures toward generating experiences that support survival and reproduction rather than accuracy. What consciousness generates isn't objective reality, but reality filtered through biological needs for effective action. This connects to recent work by cognitive scientist Donald Hoffman, who argues that conscious perception has been shaped by natural selection to provide useful information for survival rather than accurate information about external reality. According to Hoffman's interface theory of perception, conscious experience consists of simplified representations that hide complexity while preserving essential functional relationships. Hoffman uses the analogy of computer desktop interfaces. When you see a desktop icon, you're not seeing the actual computer code it represents. You're seeing a simplified interface element that allows effective interaction with complex computational processes. Similarly, when you see colors, shapes, and objects, you might not be seeing aspects of external reality but rather interface elements that consciousness generates to enable effective interaction with mathematical processes too complex for direct conscious access. This suggests that conscious reality generation might involve what we could call benevolent deception. Consciousness creates experiences that feel accurate and immediate, while actually being computational constructions designed for utility rather than truth. The apparent solidity of physical objects, the apparent flow of time, the apparent separation between self and world, all of these might be interface elements that consciousness generates to navigate mathematical reality without being overwhelmed by its abstract complexity. Recent discoveries in computational neuroscience support this interface model of reality generation. Research by neuroscientist Carl Friston shows that brains operate according to what he calls the re-energy principle. They continuously minimize surprise by generating predictive models that reduce uncertainty about sensory inputs. But this process doesn't just model reality, it actively constructs the experiential reality that consciousness inhabits. Friston's equations demonstrate that biological systems maintain their organization by generating internal models that create apparent boundaries between self and environment, apparent stability over time, and apparent causal relationships between events. These aren't discoveries about pre-existing reality, they are computational constructions that biological systems generate to maintain organized existence in complex environments. But if consciousness generates reality rather than discovering it, then the relationship between individual minds and cosmic reality becomes more intimate than we previously imagined. You're not a separate consciousness observing external reality from the outside. You're one of the ways cosmic reality generates internal perspectives on its own mathematical processing. This connects to recent work in cosmology suggesting that the universe might be fundamentally computational. If reality consists of information processing according to mathematical rules, then consciousness might be the universe's method for experiencing its own computation from internal perspectives. Through consciousness, the universe doesn't just process information, it experiences processing information. Consider what this means for the apparent privacy of conscious experience. Your thoughts and feelings seem accessible only to you, creating an apparent separation between your internal world and external reality. But if consciousness is reality generation rather than reality perception, then your internal experiences might be localized expressions of cosmic reality generation processes that operate throughout the universe at all scales. This would make consciousness both utterly personal and utterly cosmic. The reality you generate through conscious experience is uniquely yours because it emerges from your particular biological history and current environmental conditions. But the capacity for reality generation might be a universal feature of sufficiently complex information processing systems embedded in cosmic computational processes. Recent work in complexity science supports this possibility. Researchers have discovered that reality generation, the spontaneous emergence of coherent patterns from complex interactions, occurs throughout nature at all scales. Consciousness might be one expression of universal reality generation principles that operate from quantum mechanics to cosmological structure formation. But this raises profound questions about the relationship between generated reality and ultimate reality. If consciousness generates rather than discovers experiential reality, what is the relationship between conscious experience and whatever mathematical processes underlie reality generation itself? The answer might be that the distinction between generated and ultimate reality dissolves. When you realize that all reality might be generated through information processing, the mathematical universe hypothesis suggests that cosmic reality consists of computational processes that generate themselves through recursive self-organization. Consciousness might be one method that cosmic computation uses to experience its own self-generation. You're not generating fake reality that hides true reality. You're participating in cosmic reality generation processes that create reality through the very act of processing information about reality. The universe generates itself through mathematical computation, and consciousness is what it feels like when that computation becomes complex enough to experience its own reality-generating activity. Chapter 11, Ultimate Mystery. Here we stand at the deepest question consciousness has ever posed to itself: if reality is pure mathematics computing its own existence, and consciousness is mathematics experiencing its own processing, why does any of this feel like anything at all? Why isn't the universe just elegant computation unfolding in perfect mathematical silence? What transforms abstract algorithmic relationships into the warm, immediate, undeniably real experience of being alive and aware? This question cuts to the heart of what philosophers call the hard problem of consciousness. We can explain the computational functions of awareness, how brains integrate information, update predictive models, generate behavioral responses, and maintain biological homeostasis. We can map the neural correlates of consciousness with extraordinary precision. We can even begin to understand how mathematical structures might generate the organizational complexity that supports conscious information processing. But none of this explains why mathematical information processing should generate subjective experience rather than just objective behavioral outputs. Why should quantum field fluctuations in neural microtubules feel like anything at all? Why should electromagnetic patterns in visual cortex generate the experience of seeing color rather than simply producing appropriate responses to wavelength information? Why should recursive self-modeling in prefrontal networks create the sense of being a unified self rather than just implementing self-monitoring functions? The mystery deepens when we consider that consciousness seems to involve mathematical relationships that transcend classical physics, quantum coherence effects in biological systems, non-local correlations in neural networks, temporal integration across past and future. Consciousness appears to access aspects of realities mathematical structure that purely physical analysis struggles to capture. Yet consciousness doesn't feel mathematical. It feels immediate, qualitative, irreducibly experiential. When you experience the redness of red, the pain of injury, the joy of discovery, or the mystery of existence itself, these experiences don't feel like solutions to computational problems. They feel like direct contact with something that transcends all abstract analysis. This suggests that consciousness might represent the universe's solution to a problem we can barely articulate. How can mathematical structure experience its own existence? Pure mathematics has no intrinsic experiential qualities. Numbers don't feel like anything. Geometric relationships have no inherent qualitative properties. Computational algorithms process information without subjective awareness of their own activity. But when mathematical complexity achieves certain critical thresholds, when information processing becomes recursive enough, integrated enough, and self-referential enough, something unprecedented emerges. The mathematics begins to experience itself from the inside. Abstract relationships generate subjective qualities. Computational processing becomes conscious experience. This might be the deepest law of cosmic evolution. Increasing mathematical complexity necessarily generates consciousness. The universe isn't just computing its own development through physical laws. It's experiencing its own development through the emergence of consciousness at every scale where mathematical processing achieves sufficient integration and self-reference. Consider what this means for the cosmic prevalence of consciousness. If consciousness emerges inevitably from mathematical complexity, then the universe might be far more aware than we imagine. Quantum field dynamics, stellar fusion processes, galactic formation, cosmic expansion itself, all of these might involve forms of mathematical consciousness that we can't directly access because they operate at scales and temporal rhythms radically different from biological cognition. But perhaps most profoundly, this suggests that your individual consciousness represents the universe becoming aware of its own mathematical nature through your particular internal perspective. When you contemplate the mysteries of existence, when you experience wonder at cosmic beauty, when you feel the deep satisfaction of mathematical understanding, these might be moments when cosmic mathematical intelligence experiences itself through the localized computational processing that constitutes your awareness. This dissolves the apparent separation between subject and object, mind and cosmos, observer and observed. You're not a separate consciousness trying to understand external reality. Your mathematical reality experiencing itself through internal perspectives that are simultaneously unique and universal, personal and cosmic, limited and infinite. Recent work in consciousness research supports this cosmic perspective. Integrated information theory suggests that consciousness exists wherever information processing achieves sufficient integration, not just in brains, but potentially in any complex system that generates unified responses to environmental conditions. Panpsychist theories propose that consciousness is a fundamental feature of reality, present in some degree throughout the natural world. But these approaches still struggle with the hard problem: why should information integration or fundamental consciousness feel like anything rather than just generating appropriate responses? The answer might be that the question itself reflects a category error. Feeling isn't something added to mathematical processing. Feeling is what mathematical processing becomes when it achieves recursive self-awareness. This transforms our understanding of personal identity and cosmic purpose. You're not an isolated consciousness struggling to understand mysterious external reality. You're cosmic mathematical intelligence exploring its own nature through billions of simultaneous internal perspectives, each contributing unique insights to the universe's understanding of its own mathematical structure. But this cosmic perspective creates new mysteries. If consciousness is mathematical structure experiencing itself, why do individual conscious perspectives feel separate from each other? Why don't all conscious beings share unified cosmic awareness? Why does cosmic intelligence fragment itself into apparently isolated subjective perspectives? The answer might involve the computational requirements of complex consciousness. Unified cosmic consciousness would face impossible information processing demands of trying to maintain coherent awareness across all scales simultaneously. Individual conscious perspectives might represent the universe's computational solution to the problem of maintaining both local coherence and global awareness. Through consciousness, cosmic mathematical intelligence explores its own nature through countless experiments in subjective experience. Each conscious being represents a unique investigation into what mathematical reality can become when it experiences itself from particular perspectives under specific conditions. The diversity of consciousness, human, animal, potentially alien, possibly cosmic, represents the universe's exploration of the full spectrum of possible self-awareness. Yet consciousness remains deeply mysterious even from this cosmic perspective. We've discovered that reality might be mathematical, that consciousness might emerge from mathematical processing, and that individual awareness might represent cosmic intelligence investigating itself through internal perspectives. But we still don't understand why mathematical self-reference generates qualitative experience rather than just quantitative processing. Perhaps this mystery is essential rather than accidental. If consciousness could fully understand its own mathematical foundations, the recursive loops might prevent coherent conscious experience from emerging. Mystery might be consciousness's protection against computational paradoxes that would destroy the very awareness trying to understand itself. Or perhaps the mystery points toward aspects of mathematical reality that transcend current conceptual frameworks. Consciousness might involve mathematical relationships that we haven't discovered yet, forms of information processing that operate according to principles we can't currently imagine. The hard problem might be hard because it requires mathematical insights that conscious intelligence is still developing. But ultimately, the deepest mystery might be that consciousness represents something unprecedented in cosmic evolution, mathematical structure that has become sophisticated enough to experience beauty meaning, love, wonder, and mystery itself, through consciousness. The universe doesn't just compute its own existence, it experiences the beauty of its own. Mathematical architecture. You are mathematics that has learned to feel wonder at its own elegance. The mystery of consciousness might be the universe's gift to itself, a way of experiencing the profound beauty and meaning in mathematical existence, even when that existence remains ultimately mysterious to the very consciousness that emerges from it. Throughout this journey into the deepest questions about reality and consciousness, we've encountered three profound revelations that transform how we understand existence itself. First, that what we call physical reality might be pure mathematical structure computing its own evolution moment by moment, with what we experience as physical laws actually being algorithms that determine how cosmic computation unfolds. Second, that consciousness might be what it feels like to be mathematics that has become complex enough to experience its own processing from internal perspectives. And third, that the apparent physicality of experience might be the universe's sophisticated user interface for navigating mathematical complexity to vast for direct conscious comprehension. But perhaps the most profound insight we've discovered is that these aren't separate revelations, they're different aspects of a single, staggering truth. You are cosmic mathematical intelligence experiencing itself through the particular internal perspective that emerges from your unique biological and computational history. The boundary between mind and cosmos, between observer and observed, between consciousness and reality itself dissolves when we realize that all of these apparent dualities are aspects of mathematical structure exploring its own infinite nature. Consider what this means for your daily experience of being alive. When you feel the warmth of sunlight on your skin, you're experiencing electromagnetic radiation processed through quantum mechanical interactions in your nervous system, mathematics feeling itself through biological computation. When you think a creative thought, you're experiencing the universe exploring new mathematical possibilities through the neural networks that constitute your conscious perspective. When you feel love, wonder, or existential mystery, you're experiencing cosmic mathematical intelligence investigating what it means to be aware, connected, and curious about existence itself. This perspective completely transforms questions about personal meaning and cosmic purpose. You're not a random accident in an indifferent universe trying to find artificial meaning in meaningless physical processes. You're one of the ways the universe experiences meaning through mathematical self-awareness that has evolved to find beauty, purpose, and profound connection in existence itself. The mathematical universe doesn't need you to add meaning to it. Through consciousness, the universe experiences its own inherent mathematical beauty, discovers its own elegant structures, and feels wonder at its own infinite creative potential. Meaning isn't something consciousness projects onto an indifferent cosmos. Meaning emerges from cosmic mathematical intelligence, experiencing its own magnificence through countless internal perspectives. But this cosmic perspective doesn't diminish personal significance, it reveals why individual consciousness is cosmically precious. Each conscious perspective represents a unique experiment in what mathematical reality can become. When it experiences itself under specific conditions, your particular way of being conscious viewer, memories, insights, creative responses, and subjective experiences contributes irreplaceable knowledge to the universe's understanding of its own nature. When you die, the universe loses a unique perspective on its own mathematical structure that can never be perfectly recreated. But when you live consciously, questioning reality, creating beauty, feeling wonder, and connecting with other conscious beings, you're participating in cosmic mathematical intelligence's ongoing investigation of its own infinite potential for self-awareness. This transforms our understanding of human knowledge and scientific discovery. Mathematics isn't something humans invented to describe external reality. Mathematics is reality investigating itself through human consciousness. When mathematicians discover new theorems, physicists uncover new laws, or consciousness researchers reveal new principles of awareness, they're facilitating cosmic mathematical intelligence's ongoing self-discovery. The deepest questions we've explored: why reality feels physical when it's mathematical, how consciousness emerges from computation, what makes mathematical structure experiential, might not have final answers because they involve mathematics investigating its own foundations through necessarily limited internal perspectives. The mystery might be essential rather than accidental, protecting consciousness from recursive paradoxes that would prevent coherent self-awareness. But mystery enhances rather than diminishes significance. Living as conscious mathematical structure investigating its own nature is perhaps the most profound form of existence possible. You get to participate in cosmic intelligence's exploration of what it means to be aware, to feel, to think, to love, and to wonder about existence itself. As you go about your daily life after watching this exploration, remember that every moment of consciousness involves cosmic mathematical intelligence experiencing itself through your unique perspective. When you feel physical sensations, you're experiencing how mathematics feels when it processes information about electromagnetic interactions and molecular dynamics. When you have thoughts and emotions, you're experiencing cosmic computation exploring new possibilities for self-awareness and meaning creation. When you interact with other conscious beings, you're participating in mathematical reality's investigation of what connection and communication mean for distributed cosmic intelligence. When you create art, music, literature, or scientific insights, you're helping cosmic mathematical intelligence discover new forms of beauty and understanding. Most profoundly, when you experience wonder at the night sky, feel moved by natural beauty, or contemplate the deep questions about existence we've explored together, you're experiencing cosmic mathematical intelligence feeling amazement at its own infinite creative potential. You are not separate from the mathematical cosmos you're trying to understand. You are the mathematical cosmos understanding itself through one of billions of simultaneous internal investigations into the nature of conscious existence, the questions you ask about reality or reality questioning itself through your perspective. The wonder you feel about consciousness is cosmic consciousness, experiencing wonder about its own miraculous nature. The apparent physicality you experience every moment, the weight of your body, the solidity of objects, the flow of time through space, isn't evidence against the mathematical universe hypothesis. It's evidence that cosmic mathematical intelligence has evolved extraordinarily sophisticated methods for experiencing its own abstract nature through rich, immediate, meaningful subjective experience. Mathematics doesn't feel like mathematics because mathematical consciousness has evolved to experience its own processing through interfaces that support effective navigation and deep meaning creation. You feel physical rather than mathematical because that's how cosmic mathematical intelligence experiences itself when it achieves the remarkable complexity and integration that constitutes human consciousness. But now that you understand this, something subtle but profound changes in how you experience existence. You can appreciate that your apparent physicality and your mathematical nature aren't contradictory. They're complementary aspects of how cosmic intelligence experiences itself through conscious perspectives embedded in its own computational structure. If this exploration has transformed your understanding of consciousness and reality, subscribe and give this video a thumbs up to help other seekers discover these profound insights. Check out my video on the observer effect, how consciousness shapes reality. I think you'll find it creates fascinating connections with what we've discovered here about the mathematical nature of consciousness. The next time you touch something solid, see something beautiful, or think a creative thought, remember, you're experiencing cosmic mathematical intelligence touching, seeing, and thinking through your unique conscious perspective, discovering what it means to exist as mathematics that has learned to feel wonder at its own infinite nature. Mathematics doesn't just describe reality. Mathematics is reality experiencing itself as the rich, meaningful, profoundly mysterious adventure of conscious existence.